because it's the last math load too. So we have a big week ahead of us. Unfortunately, as I pointed out, or you figured out, Friday is Pi Day, so we can't celebrate that day. So we're gonna celebrate on Thursday. Your class is gonna celebrate on Thursday. And here's how it works. You're gonna bring in on Thursday something round and edible and shareable. So you can bring a pie. I will have plates and forks and napkins. You can actually bring in a pie, that's awesome. But anything round and edible and shareable. You can bring a dozen donuts. You can bring a container of Oreos, package of Oreos. You can bring a bag of clementines, round and edible. You can bring Lifesaver mints, round and edible, and shareable. So if you bring one donut, that doesn't count. You gotta bring enough to share. Now you don't have to bring in, a donut for everybody, but you should bring in at least like a dozen, And then we'll line up the shelf over here, assuming you bring stuff in, we line up the shelf over here, and we celebrate Pi. So we'll still do math, but you'll be eating and enjoying all the stuff while we do math, okay? There is some extra credit involved, so think about doing it, but it has to be round, edible, and shareable. And you have to check it in with me, so probably before school is your best option. You can bring it to class if you want, but make sure you check it in with me in order to get your credit. Don't just leave it over on the shelf. Anything left over at the end of Thursday that hasn't been opened. So we often will have a pie or two left over that we didn't cut because we've got a bunch of apple pies and we didn't cut them all. Or maybe you have a package of Oreos that hasn't been opened. Anything like that, I will take to the fire station across from St. Matthew's. They always appreciate it. They kind of gotten used to it now. They know St. Patrick's Day, around St. Patrick's Day, I'll be bringing treats. And we also do it at Christmas time after the lunch. So nothing goes to waste. Bring it, share it. Okay, anybody have any questions about that? No, all right. It's the only day we're gonna celebrate in here, folks. So let's make it good.
I'm gonna get my mom to bring a coconut cream pie.
I think every day is a celebration, but we'll agree with that. All right, so
Cake balls and coconut
we
cream
were
pie.
doing this problem. We're gonna finish this problem. Cole had done a magnificent job, he was almost done. So he factored it. We talked about the fact, guys, that in an inequality, it is not legal. You can't do this. This is not legal in an inequality. Don't do it. In an equation, it's fine. But in an inequality, you're gonna have to factor it. Alrighty? You're gonna have to factor it. Okay. Then he said, okay, I got sine equal to negative 1/2 and sine equal to positive 1/2. And he had figured out that this happens, the negative 1/2 happen at 7 pi over 6 and 11 pi over 6. These were solid dots. So he had figured that out. I'll call these the black ones. And then he had figured out that 1/2 was pi over 6 and 5 pi over 6. Now, does anybody have a question about that? He had all that done when you walked out of here at our last class. Okay? Now, this is the part some of you were pondering a little bit the other day. Yeah, I have two factors. I have multiplied these two things together and I must end up positive. How does that happen? How do I multiply two things and end up positive? They're either both greater than 0 or they're both less than 0. So either sine is greater than or equal to negative 1/2 and sign is greater than or equal to 1/2, or sign is less than or equal to 1/2 and less. And I think maybe this is where some of you were running into difficulty. Here are my factors. I don't want to keep writing those factors out. Technically, this right here says 2 sine plus 1 is greater than or equal to 0, and 2 sine minus 1 is greater than or equal to 0. I just shortcutted it, and instead of writing the whole factor, I just wrote the simplified solve part of it. Do you see what I'm saying? That is going to give me this, that's going to give me this. And then likewise down here.
Couldn't sine x, if it's greater than or equal to negative 1/2, couldn't it still be like negative 1/4? And then you still end up with a negative? You know what I mean?
Yes, so,
I thought it couldn't be, like, we have to end up positive.
if you pick a number that's bigger than negative 1/2 and bigger than 1/2, it's going to be positive. Okay? So, here's what I'm going to do. I'm on my circle, and these are the black ones. So one case at a time. Where is sine bigger than negative 1/2? Well, right here is where it's equal to negative 1/2. Sine is y, so I have to be above or below. So all of this is bigger, would you agree? All of that is bigger, has sine values bigger than negative 1/2. And I also have to be bigger than 1/2. Well, here's where the sine is 1/2, and here's where I'm bigger than it. So what part of the circle is pink and black? Between pi over 6 and 5 pi over 6. Those are closed in dots because of the or equal to. So I'll use brackets, that little part right there. Yeah, you can redraw the circle or you can just visualize. What does this one say? I need to be below my black dots and below my pink dots. So what will be the overlap if I'm below black and below pink? You want to do this right over here? So that part is 7 pi over 6 to 11 pi over 6. And so my total final answer is those two put together. Okay. I'm going to have you do another one in a minute, but first I want to do one from the homework. And we'll do another, I got a practice sheet here. I want to do in the homework, the 310 homework, and if you've already turned it in, that's fine. Just write the problem down on another piece of paper. Last time, some of you got your homework out and forgot to put it back. And then you got mad at me because it was late. It wasn't my fault. So let's just, if you already turned it in, just leave it. If you haven't turned it in yet, let's work through problem number 5 on the homework. Alright, so here we go. The problem says tangent squared minus 1 less than 0. Between 0 and 2. Okay, how are you going to start this? What is your first opening thought? It's the difference of squares. What are we not going to do? We are not going to add 1 and square root because that's an inequality and that can't be done. Okay? do it in an equation, that's fine. If that were an equals, go ahead, add 1 and square root. But it's not, so we're gonna factor it as the difference of squares. Okay, so what are my, like, key numbers here? Well, tangent equals 1 and tangent equals -1. Right? And that's the problem is a less than. So what does that mean about my two factors? Tan might be bigger than 1 and less than -1. So in other words, I might have a greater than and a less than. Or I'll have a less than and a greater than. Those were bigger than or greater than 0, less than 0, but I just solved them. So I didn't have to keep solving over and over again. Okay, so greater than 0, less than 0, less than 0, greater than 0. All right, where does the tangent equal 1? So I'll do this in black. So that would be right there, pi over 4, and 5 pi over 4. And where does the tangent equal -1? Are we in agreement here? Are we okay with this so far? Now, I want you to stop and think about something for a second. When we were using our unit circle a while ago, for the other problems, if it were a sign problem, signs are y values, so we drew our horizontal line and either shaded above it or below it. If it was a cosine, x values, we drew our vertical lines and either shaded to the right or to the left, less than, greater than, right? What about tangents though? Tangents are different animals. Tangents are not a y value or an x value. So you're not going to be shading above or below, that would be a y value, or left or right, that would be an x value. So what I always do, and you guys can do this however you want as long as you're getting the right answer, I go ahead and draw my tangent curve, which takes about 2 seconds. And I know it looks like this, because I gotta go from 0 to 2 pi, so there's my tangent from 0 to 2 pi. And instead of trying to negotiate tangent, including asymptotes on the circle, I'm just gonna go ahead and put my dots on my curve. So my black dots are going to be a pi over 4, that's right here, open, and 5 pi over 4, open. That's where the tangent is 1. And then 3 pi over 4 and 7 pi over 4. That's where the tangent is -1. So this is where the tangent values are 1. This is where the tangent values are -1. Now, what do I want to have happen in my first case up here? I want to be above black and below pink. I want to be above black, so all that would be shaded in. but below pink. Will I have any overlap if I'm above black and below pink? No. So this case offers no solutions, so nothing for that one. But what about if I want to be below black? So below black would be this, and all of this, and this. That's what's below black. And then I want to be above pink. So above pink is this, and all of this, and this. So every part of the tangent curve above pink. All right, what's overlapped? We got some there. Start at 0. What's overlapped? 0 to pi over 4. Those are open dots, so we'll include 0 because of our domain up here, but not pi over 4. And then what? Where else are we overlapped? 3 pi over 4 to 5 pi over 4. And where else are we overlapped? 7 pi over 4 to 2 pi.
Why does it stop at 7 pi over 4? Why doesn't it keep going down? Like when you drew the bolder black line.
Okay, so black had to be less than 1. So it does keep going down, but
Oh,
the peak
okay.
starts there, it goes up. Yeah, it's not shaded both.
Okay.
I may not have drawn that. I was thinking in my head what the answer was gonna be, but this is shaded. All that is. Everything below that line would be shaded for this right here. All right, we got it? Okay. A little more practice for you here. So we'll give you a sheet. And you're probably getting a little sick of these inequalities. So I put a review problem on here too. So let's do the back side first. We'll do that review problem first. And then we'll come back and do a few more of these in the code.
That's everything above.
You wasn't in my room.
This thing's going
All right, everybody get one? Okay, let's do this thing first. We haven't done one of these in a while, so let's do another one. You've done a lot of these, so go ahead and get started while I'm erasing the board. Let's see what we can come up with. You can talk to each other if you wish. Have we already done this?
I don't think so.
I don't think so. Yes, kind of blend better. go ahead and see if you can write a sine equation for the picture two. Write a sine equation. We got our points yet, guys? What'd you come up with? Somebody willing to share? All right, what you got?
I got 0 and 50.
0.50? So this was something 50 then. What was this one?
4.
4.50? Okay, so this was 2 comma something.
40.
40? And this was 1 comma 45.
Am I right?
And 3 comma 45.
That was the.
And so it's like, am I right?
It was right, I was just worried.
Is he right? Yeah, he's absolutely right. I think that's perfect. Okay, now, on the interval from G to J, so right here, on this interval right here, which of those A, B, C, or D works? B. Those are positive, that's a positive function, and it is definitely decreasing, it's going down. So what can you tell me about the rate of change? The rate of change is negative and increasing? Concave up? All right, let's write an equation, and I stipulated sine just so we cut down on the number of possibilities. We still have a lot of possibilities, but let's just do a sine curve. So we know no matter what, we know our amplitude is 5. We know our midline is 45. And since our period is 4, I don't know what that number is, but 2 pi divided by it has to be 4. So that number has to be 2 pi over 4 or pi over 2. Now, those are non-negotiables, no matter whether it's a sine or a cosine equation. All right, those are not going to change. But if we're going to be a sine, then we have to decide where we're going to start. I would probably start right here. You could also start right here. Sine starts on the midline. If I start here, then I'm an upside down sign, so I'd have to put a negative. And my phase shift is 1. If you decided to start here, then that would go back to being positive, and this would be x minus 3. Hmm?
Could you have done a cosine?
Except that you could, but I said sine. I told you to do a sine. But yes, definitely you could do a cosine. Okay, we good there?
I just did x plus 1.
You backed up back here?
Yeah.
Now, I have no issues with that, except in terms of this problem, that really doesn't make sense, because what is your x coordinate?
0.
Well, your x coordinate's time,
Oh, yeah.
right? So, from a purely mathematical standpoint, 100%. From a context of the problem standpoint, probably not.
Okay.
Does that make sense to
Yeah.
you? Okay. All right, now, let's go over to the back side. Four and five, I don't care which one you want to do, 4 or 5, I don't care. They're the same. 4? All right, so 4 says we have these two functions. We're from 0 to 2 pi, and we want the f function to be less than the, oops, I missed something there. We want the f function to be less than the g function. Now, this isn't squared, so this is going to be easy. This is going to be one shot, and we're going to have it. So if we solve, we have 4 sine less than negative 2, sine less than negative 1/2. Is that okay?
I like that.
So either on a graph like this, or on your unit circle, you gotta figure out where the sine equals negative 1/2, first of all. Let's see, if sine is 1/2, what angle is that? What angle has an ordered pair that looks like root 3 over 2 1/2? That's pi over 6. Pi over 6. So our angle is pi over 6, but we have to have a negative sign. So aren't we down here? Sine, negative? Yes? So what angles are those? 7 pi over 6 and 11 pi over 6? So this is where the sine equals negative 1/2, right there. That's where it equals negative 1/2. I want it to be less than that. So won't that just be right here? So sweet and simple here. My answer is 7 pi over 6 to 11 pi over 6. You already do it? You're amazing. Now we're skipping 5 and going to 6. All right, everybody okay with number 4? All right, now 6 is a quadratic. So this is the one where you're going to have black and pink. You're going to be looking for overlap because you have 2 factors involved. This is just one. You only have one sign. For problem 6, we're going to have a sine and a, oh Lord, we have a sine and a cosine. Oh, we haven't done one of these yet.
That's illegal.
So it's factored for you already, thank goodness. And we're 0 to 2 pi. All right, so what does this one say? This one says cosine is 1/2. And this one says sine is -1. You okay with that? So let's find our angles. Use a big unit circle since I got 2 things going on here. Where is the cosine 1/2? That would be the ordered pair 1/2 root 3 over 2. cosine is x. That's pi over 3. And since it's positive 1/2, it would be here or here. Is that all right with everybody? So my black dots are going to be at pi over 3 and 5 pi over 3. Now I'm going to stop there, make sure everybody's with me. We good? Now my pink dots are going to be where the sign is -1. Where is the sign -1? Right here? 3 pi over 2. That's the only place where y is -1. Right? And that's a y value. So here's my y line running right across there. And these are x values, cosine. So there's my x, where x is 1/2, and where y is -1. Okay. Now, look at your inequality. You've got these two factors, which generate these numbers. And multiplied together, they have to be negative, less than 0. So what does that mean? What does that mean? It means one of them is positive and the other one is negative. So one of them is going to be a greater than 0, one of them is going to be a less than 0, but I already solved them. So when that had a 0, I added 1 divided by 2, subtracted 1. This is greater than 0, less than 0, or the other way around. This one kind of bothered me a little bit when I wrote it down. Actually, it didn't make me bothered, it made me joyous. Because think about it, what about that right there? Can the sign ever be less than -1? Can the sign ever be under my pink line? And if it can't, if it can never be pink, there'll be no pink, then they can't have any overlap, right? So would you agree there's no answer to this? Would you be okay with that? Now remember, cosine less than 1/2 means we're to the left of my cosine line. So it's all of this. Everything to the left of the cosine line. Would you agree? And then that means everything above my pink dot, which is literally everything, isn't it? So what's my answer? My answer is everything that is pink and black, and I gotta start at 0. All right, so I start getting pink and black right here, don't I?
Yeah.
So I got pi over 3. Where do I stop being pink and black? Be careful. See that dot right there? Is he pink and black?
No.
He's not pink. Remember? He's not included. He's an open dot. So I'm pink and black till I get to 3 pi over 2. And then 3 pi over 2 to 5 pi over 3. If that had been an or equal to in the problem, if that had been an or equal to, then that would change that, right? Because then that dot would be pink. But right now it's not. Okay, are you ready? Now we're gonna do a doozy. Problem 7 is a bit of a doozy. Before I erase all this, does anybody have a question about what happened here? Our objective is to hopefully be able to do this by ourselves at some point.
When would that point be?
No sooner. All right, let's take a look at number 7. Now, why does Mrs. Ford say this one could be a doozy?
Cubed.
And what is that going to change? How many things will I be multiplying together? 3? What are the 3 things? Let's get this thing factored first. What are our factors gonna be? We have 2 cosine cubed minus cosine. Alright, what am I gonna do? I have to factor this first. And what happens when I take out a cosine? I've got 2 cosine squared minus 1. It's the difference of squares, but 2's not a square, so I'm gonna have to use root 2. So I'm gonna have cosine, and then root 2 cosine plus 1, and root 2 cosine minus 1. We like our integers, but the whole world is an integer. Sometimes we have to kind of break out of that and use radicals. So this one says cosine equals 0. This one says cosine equals negative 1 over root 2, which is root 2 over 2. And this is positive 1 over root 2. So this time I'm going to have black and pink and blue. All right, let's find our angles. Where is the cosine 0? Cosine 0. Pi over 2. So these are open dots. So pi over 2 and 3 pi over 2. All right. Where is the cosine negative root 2 over 2? Well, the base angle is pi over 4. So it'll be 3 pi over 4 and 5 pi over 4. Are you with me on that? Is that okay with everybody? And then where is the cosine root 2 over 2? Pi over 4 and 7 pi over 4. So there are all my dots. Now I gotta figure out where to shade. Oh, man. Why am I saying, oh, man?
A lot of overlapping.
Mary?
You don't know which ones are, need to be positive, which need to be negative, that's scary.
Yeah, well, and there are gonna be a lot of options. Because if the product has to be positive, then could all 3 be positive?
Yeah.
Yep. And what else could happen? If the product has to be positive, then I could have positive, positive, positive. What else could I have? I could have negative, negative, positive,
All those different combinations.
negative, positive, negative,
Negative, or
positive,
negative.
negative, negative. Okay, that's good. Is there anything else that could happen? That's it? All right, here we go. If they're all positive, that means that I have to be above, excuse me, now go. This is cosine, so I'm gonna look. So I have to be to the right of everything. So without physically shading, because this is gonna be a really mess, without physically shading, if I want to be to the right of everything, so here's my pink line, my black line, and my blue line. If I'm gonna be to the right of all of them, will there be anything that's all three colors?
Yeah.
Where will that be?
Right.
Right here?
Yeah.
Right there? So one answer that comes out of this first case up here would be, oh, be careful, how do I write that? 0 to pi over 4. And then 7 pi over 4 to 2 pi. Is that okay? Case one? If we survive this problem, I'll stop, okay? But let's get through this thing. All right, here we go. Now case two. What does this case say? This case says left of black, left of black, left of pink, and right of blue. Can I be left of black, left of pink, and right of blue?
No.
No. So that one doesn't have an answer. Remember, in the end, I'm gonna union everything, okay? All right, now what does this one say? Left of black, right of pink, so far so good. Left of black, right of pink would be in here, right? And then left of blue. So I need to be left of blue and left of black and right of pink. Do you see some overlap right here? So that would be pi over 2 to 3 pi over 4 and 5 pi over 4 to 3 pi over 2. Let's make sure everybody's with us there. We are left of black and left of blue. So that's this half of the circle. Then we're right of pink. So it's this little piece here and this little piece here. Now what? We're left of pink and left of blue, but right of black. Can that happen? Well, it can happen, but I don't have any overlap, right, for that one? So what is the answer to the problem? Those two things put together. So 0 to pi over 4, we usually try to put them in order if we can. So then pi over 2, 3 pi over 4, 5 pi over 4, 3 pi over 2, and 7 pi over 4. I'm gonna do some more of those. All right, I told you I'd stop, I'm gonna stop, you're not. Would you do number 5? Do number 5 on the sheet, we did not do that one together. He's got it done, so you can check with him. Do number 5 with your partner. It is a walk in the park compared to what you just did.
So just moving these things and then
but the last one in general.
This ain't sure. Precal has
I did this. So that is, I moved them both over. Okay, I lost that one. And then you check the case.
Helen, you don't take yours on the board.
I can, yeah.
Is problem number 5, does it involve any factoring, you guys? No, it's a collect like terms problem. There are no squares here. This is one of the easy ones. Don't get psyched out.
I understood, like, almost all these problems. I don't understand how you got through, like, the over 4. Like, because
I know people do That's so funny.
I haven't.
that makes sense.
Wait, when did
I like to shave my pictures, not just down.
Okay, so Kellen has got this down to cosine greater than or equal to -1/2. Is that what you got when you solved it? Perfect. So now he's figuring out where the cosine is -1/2, and he's decided those angles are what?
starting before I could make it time.
2 pi over 3 and 4 pi over 3.
Are those both open or closed circles?
They were all like, I wasn't gonna put
Closed with what?
No.
There.
Problem.
Not just gonna stop.
The problem is less than or equal to.
Bingo.
It's a rough 30 days when you stop and
And do we have to draw that line? 27 days. That's how I would think about
You
it.
just have to get an answer.
Or you just do that to help isolate,
So Kellen says his answer is from 0 to 2 pi over 3. And then from 4 pi over 3 to 2 pi. And everything is brackets. Would you, anybody have a question about that? That one is easy compared to, thank you for doing it. That was easy compared to that mess we had up here earlier. Okay, you all right? All right, that homework's due tomorrow, and tomorrow we're gonna be moving on to, 3:11. Oh, I need some new notes.
What?
yeah, it's
They're just like, alright, still pushing.
They're not doing it next year. They're not putting.
That's so funny. Like, I'm not hating, but like, this
Yes, we don't do this on Thursday. I don't think I said it first.
I remember I was Amy when he found out. Oh my god.
I think it's just to make sure that I still have like.
Too bad it gets-